Hello everyone, welcome back to this video series on clinical SAS ADaM programming. In this video, we will see how to create grouping variables. Grouping variables can be of character type or numeric type. So here we will see how to create character based grouping variables and associated numeric equivalents. So let us go to the lesson description. So if you see, for analysis purposes, sometimes we may want to group or categorize certain information. ADaM specifies a standard convention for naming these grouping variables that we may have to create. As per ADaM standard, these variables have to end with a suffix of GRY, where Y stands for grouping algorithm scheme. For example, there can be two different grouping algorithms required for age variable. So we name those groups as GR1 and GR2. So 1 indicates that the grouping algorithm 1 is applied and 2 indicates that the grouping algorithm 2 is applied. As noted above, GRY is a suffix and the prefix can be the parent variable name where applicable. Say for example, if we are creating grouping variables for age, so the names can be age group 1, which is age GR1 and age GR2, etc. And similarly, if you are creating grouping variables for BMI, baseline BMI, and the variables can be named as BMI group 1, BMI group 2. Note that only a fragment of the parent variable name is used here as a prefix. So instead of using the complete BMI BL, we just used the text BMI when creating the grouping variables. And grouping variables for site ID can be site group 1, site group 2, etc. Note here again that only a fragment of the parent variable name is used as a prefix. So GRY variables are used to represent the character categories, and we can use GRYN series to create numeric equivalents for each value in GRY. For example, age group 1N can be used to store the numeric variant of categories of age group 1. So what do we see in this lesson? So in this lesson, we will see examples of creation of grouping variables for age, BMI, and categorization of sites. So now let us move to the specification for this. So here we have the specification where we have the variable name, label, and the derivation logic provided. So the first derived variable that we are going to create is BMI GR1, which is pooled BMI group 1. So it says derive this variable using ADSL BMI BL. So the input variable for BMI group is BMI BL. So if missing less than BMI BL less than 18.5, then we are being asked to set the BMI group 1 value to underweight. And then else if it is in between 18.5, but if it is 18.5 less than or is equal to BMI BL, but less than 25, we are being asked to set it to normal weight. Else, if it 25 less than or is equal to BMI BL less than 30, then we are being asked to set it to overweight. Otherwise, if BMI is greater than or is equal to 30, then we are being asked to set the BMI group value as obesity. So this completes the derivation for BMI group 1. Now let us see the next variable, which is numeric equivalent of BMI group 1, which is BMI GR1N. So the N at the end indicates that it is a numeric counterpart of the parent variable. So here the derivation says derive this variable using BMI group 1. So after deriving BMI group 1, we need to use the values present in BMI group 1 to derive BMI group 1. So if BMI group 1 is equal to underweight, we are being asked to set a value of 1 in group 1N. And then when it is normal weight, we are being asked to set to 2. When it is overweight, we are being asked to set it to 3. And when it is obesity, we are being asked to set it to 4. So now let us move to the next grouping variable, which is for age. So it says age group 1, pooled age group 1. So the derivation says derive this variable using ADSL.age variable. So if missing less than age less than 60, so then set to less than 60 years. And else if age is in between 60 and 75, inclusive of 60 and 75, then we are being asked to set the group as 60 to 75 years. Otherwise, if age is greater than 75, we are being asked to set it as greater than 75 years. And then we have the numeric version of age group 1. It says when it is less than 60 years, we are being asked to populate as 1 in age group 1 n variable. If it is 60 to 75 years, we are being asked to set a value of 2. And then else, if it is greater than 75 years, we are being asked to populate with a value of 3 in age group 1n. And then we have age group 2 as discussed in the lesson description. So there can be multiple grouping algorithms for a single variable. So here we have seen one categorization or grouping for age algorithm where it grouped into three categories: less than 60, 60 to 75 and greater than 75. But here in age group 2 we have a different algorithm. It says populate as less than 80 years if age is less than 80. Otherwise, if age is greater than or is equal to 80, we are being asked to set the value of greater than or is equal to 80 years in age group 2. So there are two different grouping algorithms. The first one contained three groups and the second one contained two groups. Where the groups in age group 2 are less than 80 and greater than or is equal to 80. So the Y was indicating the grouping algorithm sequence. The first one was grouping algorithm 1 and the second one is grouping algorithm 2. And then we have age group 2n, so which is numeric counterpart for age group 2. So here we are being asked to set the value of 1 in age group 2n when the age group 2 value is less than 80 years. And then when it is greater than or is equal to 80 years, we are being asked to set a value of 2. And then comes our next grouping variable, which is for site, which is site group 1. So it says pooled site group 1. So derive this variable based on ADSL site ID. So the input variable is site ID for this grouping. And the second component of the derivation says count the number of subjects within each site ID. So if there exists less than 10 subjects in any site, pool all such sites and create a site group as pooled group for these sites. Else, if the number of subjects in a site is 10 or more, then site group 1 will have the same value from site ID. So we need to check how many number of subjects are present in a site ID, and we'll have to pool all the sites where the number of subjects in that site is less than 10 and assign the value of pooled group to that site group 1 variable. Otherwise, if it is 10 or more subjects, we simply need to put the value which is present in site ID in site group 1. So note that we do not have a numeric counterpart for site group 1, which may not be needed for creating your TFLs. So now let us move to the SAS program. So before that, let us take a look at the input data set. So we are using ADSL as input. We have useSubj ID, site ID, age, race, BMI BL, height BL, and weight BL. So we'll be using this data set as input and creating our new grouping variables. Now let us move to the programming. So here I have a program with the name of ADaM C1001L105 underscore data stored in a particular folder, and I have the code that generates the input data for this lesson, and I am calling that program in this program using %include statement. So when this line of code is executed, the entire SAS code present in this data SAS program will be executed and all the data sets would be available for me in work library to program this lesson. And now I am jumping into the actual task. So I am creating a copy of ADSL and naming it as ADSL01, and then jumping to the actual variables derivation. So we will now first see the derivation for age groups and also BMI groups, as they are directly relying on the input variable BMI, BL and age. So here I am using a length statement to assign the length for the newly created age group variables. So it is a good practice to assign lengths before creating the new character variables so that the values may not get truncated. So if we do not assign a length for character variables, what will happen is, based on the first assignment, whatever is the number of characters assigned to the in the first instance, that value will be used as the length of that variable. Say for example, here I have 10 characters assigned, the length of the BMI group would be set to 10. And if I assign a text in the downstream processing which has more than 10 characters, that text would still be truncated to 10 character because the first instance was used to define the length of the character variable. So in order to avoid such kind of truncations, what we do is we assign the length of the character variables before creating them. So I am using a length statement and I am assigning the length for BMI group, age group 1 and age group 2 as these three other character variables that we are going to create. So now we are jumping into the creation of BMI group, group 1 and BMI group 1N. So in the specification, the derivation for BMI group 1 was saying that as it was derived based on the values present in BMI group 1, but the underlying condition for each of the BMI group 1 is the same as the one which we are creating for BMI group 1. So I am using this do group processing to create both variables simultaneously. So I'm checking if BMI is not missing and less than 18.5. If that is the case, I'm assigning the value of 1 to BMI group 1N and then the text be underweight to BMI group 1 variable. And next I'm checking if 18.5 is less than or is equal to BMI BL less than 25. If that is the case, then I am assigning the text of normal weight to BMI group 1 and then the two text for and the number 2 for BMI group 1. So this is what was needed as per the specification. If we go back and then see when was BMI group 1 and supposed to be 2. So here if we see set to 2 when BMI group 1 is normal weight. So here when I am checking for the condition of creating normal weight, so I am assigning the or creating the relevant counterpart numeric variable as well. So and then next we will move on to the creation of the variable, the third category for BMI group, which was for overweight. So we are checking if 25 less than or is equal to BMI BL less than 30. Then if that is the case, we are assigning the number 3 to BMI group 1 and then the text overweight to BMI group 1. Similarly, we are checking if BMI BL is greater than or is equal to 30. If that is the case, we have assigned the value 4 to BMI group 1 and then the text obesity for BMI group 1. So this completes the derivation of two variables, which is BMI group 1 and BMI group 1N. And now we will move to the first categorization for age variable, which is age group 1 and 1N. So here the first categorization grouped into three. So which was less than 60, 60 to 75 and greater than 75. So here I'm checking if missing less than age less than 60, then I am assigning a value of 1 to age group 1N and the text less than 60 years to age group 1. So you may get a doubt like why am I checking for missing less than. So in SAS, missing value is considered as the lowest value. If we just simply check for age less than 60, we will get the label as less than 60 years even when age is missing, which is not appropriate. So I'm checking if age is greater than missing and less than 60. So the convention, one convention to check for that condition is to check if missing less than age less than 60 and then assign the values appropriately. And then the next one was to check for whether the age is in between 60 and 75 inclusive. So we are checking 60 less than or is equal to and then age less than or is equal to 75 and then assigning the text of 60 to 75 years for age group 1 and the number 2 for age group 1N. And similarly, we are checking if age is less than greater than 75 and assigning the text greater than 75 years for age group 1 and then the number 3 for age group 1N. And then this completed our derivation for age group 1 and it involved three categories. And then next is our second grouping variable for age. So age group 2. So it involved two categories less than 80 years and greater than or is equal to 80 years. So I'm checking if age is not missing and whether it is less than 80. If that is the case, I'm assigning the text less than 80 years and the value of 1 to age group 2N. And then we are checking if age is greater than or is equal to 80. If that is the case, we are assigning the number 2 for age group 2N variable and then assigning the text of greater than or is equal to 80 years for age group 2 variable. And this completed the derivation for age group 2 and 2N as well. So now let us see what is the output dataset that we created here. The output dataset that we created here is ADSL02. Let us quickly see the values for these created variables in the output data. So let's go to ADSL02. Let me zoom in this a little. So first thing we created was BMI group 1 and 1N, and then age group 1 and 1N, age group 2 and 2N. So now let us quickly see when the BMI was less than 18.5, it was supposed to be underweight. So we are quickly cross-checking if for one of the values where the value is less than 18.5, whether it is underweight or not. So it is populated correctly. So let us quickly cross-check for the case where it is greater than 30. So greater than or is equal to 30, it was supposed to be obesity as per the specification. Let's see if it is actually the case. So I filter for a row whose for a subject whose BMI was 33.6 on this. So this was supposed to be obesity. So this is coming correctly. And then the associated numeric value was supposed to be 4. So it is coming correctly. So let us cross check some value in between 25 and 30. So if it is uh, 25 and 30, it was supposed to be overweight, so it is coming correctly, and the associated category number was 3, so it is coming correctly here. So we have this derived correctly. And now let us take a quick look at the age group 1. So it involved categorization into less than 60, 60 to 75, and greater than 75. Let us filter age variable which has a value of less than 60 and cross check whether the value label is coming as correctly. So it is less than 60 years. So let us filter some age value in between 60 and 75. So the value in age group 1 is supposed to be 60 to 75. So it is the case. Let us filter some age value which is greater than uh, 75 and then see if the label is displayed correctly. So it is coming as greater than 75 years. So it is coming correct. So let us now select all. And then the third group was less than 80 and greater than 80. So if we take a quick look here, so 63 is supposed to be having less than 80 years, which is coming correctly here. So let us take a value which is greater than 80 and then see if it is the case. So in all the cases, we have 4 subjects whose age value is 84. On all those records, the value is supposed to be greater than or is equal to 80 years. In age group 2, it is coming correctly. And we only had 2 categories, and the associated numeric variable when greater than or is equal to 80 years, it was supposed to be 2. So it is populated correctly. So now we visually examine that our code is working fine. So let us now move on to the next variable derivation, which was site ID. So as it involved some counting the number of subjects, so we are keeping this in the next step. So here I am counting the number of records within each site ID present in ADSL 02. We know that in ADSL we will only have 1 record per subject. When I create a table for site ID, it creates a table containing the number of records within each site ID value. So if number of subjects, if 1 record is present for each subject, the number of records is equal to the number of subjects. So I am creating a dataset called site ID 01 to fetch the number of records present in each site ID value. Now let us take a look at the site ID 01 dataset. So here I have 3 distinct values present in site ID, so which is 701, 702, and 703. So there are 41 records with value of 701 and 1 record with 702 and 3 records with 703. So as we know that in ADSL there is 1 record per subject, so we can call this as 41 subjects in 701 and 1 subject in 702 and 3 subjects in 703. As per the logic, so whenever the count is greater than or equal to 10, so we just had to populate the site ID value in site group 1. Otherwise, we had to populate it as site pooled group. So now let us see how this is being done. So we are using site ID 01 as input and then creating a dataset called site ID 02. So here I am checking if the count is less than 10. If that is the case, I am assigning the value of pooled group to site group 1 variable. Otherwise, so I am assigning the value of site ID to site group 1. So let us take a look at the site ID 2 dataset to see how that looks. So here if you see, so in these cases, the number of subjects in these sites are less than 10. So it was supposed to take the value of pooled group. So we have pooled it. And then in the cases where it is greater than or is equal to 10, so it is supposed to be the same value in site ID. So we have assigned that here. Now this data set has like what should be the site group value for each site. So now we need to use this information and bring this site group variable into the parent data set by merging at site level. So we will do that in the next step. So we are sorting our ADSL02 data set based on the values present in site ID. Similarly, we are sorting it for site ID02 data set based on the values present in site ID, and then merging ADSL02 and site ID02 based on the values present in site ID, and then to pull the site group 1 into our ADSL02. So let us now take a look at ADSL03 and examine if the site group is 1 is populated correctly. So let's go here, ADSL03. So we now have site ID, site group 1 variable pulled from site ID 2 dataset into our ADSL2 dataset, and we named it as ADSL03. So let us see, in all the places where it is 701, we know that there were more than 10 subjects. The site group 1 was supposed to be the same value as in site ID. So here for 702 and 703, the number of subjects were less than uh, 10. So it was supposed to be pooled group in site ID 1. So this now completed our site group 1 derivation as well. Finally, I am creating a dataset named as output using ADSL03. I'm just keeping the required variables and then ordering them in a logical sequence using return statement. So this completes the derivation for our grouping variables. We have created character versions and associated numeric variables for groups. So this is how you can create grouping variables. Thank you for watching and keep learning.